The aim of this project was to implement real-time online multiplayer gaming for the web using only standard HTML5 web technologies. Real-time multiplayer gives the impression that you and other players connected to the game are playing in the same game world, using a range of techniques to try and synchronize the state of objects and events in the game. Real-time multiplayer is massively popular in commercial PC and console games, such as Call of Duty, Counter-Strike, and Battlefield, but has barely made an appearance in the web game world. Recently, with the improvements made to HTML and web technologies, there seems to be a possibility for real-time multiplayer to emerge into the web game market, which is a large industry mostly ruled by single-player flash games. The game developed uses a client-server model, where users playing the game do so by using the client application and connect through the network to a dedicated server application. Websockets were chosen for the transmission of messages and connection between clients and the server. The client game application was written in JavaScript using HTML5 and the pixi.js library for graphics. The server application was developed in C++ using the lightweight libWebsockets library for networking. The server application is a standalone executable file and would be available to download by anyone who wishes to run their own server. Players in the game control a tank in real time using their mouse and keyboard. Users can maneuver through a simple game world and fire their weapon at other players, who are also users connected to the same server. There is a delay and bandwidth restrictions when sending data through the network, so this shared game world is actually simulated using the authoritative server model, made popular by early first-person shooter games such as Quake. The actual game state of objects in the game world is stored by the server, which has authority over the state. This is the master game state. The server updates the game state several times per second, each time known as a tick. A tick rate of 30 ticks per second is usually enough to give a smooth gaming experience. Players influence the control of their tanks by rapidly sending input messages to the server, at the same rate as the tick rate of the server. These input messages contain the button states for the player's controls, such as up, right, down, left, and fire, as well as the direction their tank turret is aiming. In the client application, update messages are received from the server every tick. These update messages contain a list of events and states from the master game state. The client application then uses this data to recreate an approximation of the master game state and display it graphically to the user. This approximation, when executed correctly, is enough to give the players the impression of playing with each other in the same game world and seeing the same game state. Because update messages received from the server aren't necessarily going to be smooth enough to give a good simulation of motion for game objects, interpolation was implemented to smooth out the positioning of the tanks. This means that the tanks will store state updates and smoothly reposition graphics between these states as the screen redraws. Here we can see the game before interpolation was added. The movement is choppy and unconvincing. Here, with interpolation, the tanks move smoothly and do not break the immersion of the game world. Because messages are being sent and received at such a rapid rate across the network, it was important to reduce the bandwidth as much as possible. Normally, WebSockets are used by transmitting plaintext data or JSON strings. For this project, binary messages were used, and the protocol was designed by specifying the data length of every element being sent in the message. This meant that functionality to read and write using binary buffers was implemented. Bit-by-bit reading and writing was implemented in order to reduce the size of the tile-based game map when being sent to connecting clients. The final result is a game which plays smoothly and immersively and gives the impression of competing in the same game against other players across the internet. There are no downloads, plugins, or configuration needed to play the game. It's simply contained inside a web page. Because of the use of standard web technologies such as HTML5 and WebSockets, the game is widely cross-platform, running on any device whose browser supports these modern technologies. Here we show the game running inside the web browser on a mobile platform using a tablet. Whereas before it was difficult to both find real-time mobile web games and also real-time online multiplayer web games, both have been achieved with this project. Using this technology, a player could link their friend the URL to the game, and their friend, using a tablet, PC, or mobile device, could start playing against them immediately, with no downloads or configuration.